Okay, so get this. Today we're gonna really dive deep into how our kidneys handle glucose.
Yeah.
You know,
It's pretty
the sugar that fuels our bodies,
Right.
right?
Yeah, so.
And it's kidneys are these incredible filters.
Yeah.
But how do they know
Right.
what to keep and what to let go of?
It's a great question.
Right.
Yeah.
So to help us figure this whole thing out,
Okay.
we've got this physiology handout
Right.
from Dr. Rasha Eldeeb,
Oh, fantastic.
who breaks it all down into these really
yeah.
cool steps.
Love it.
Yeah.
So this process, I think it's something that we don't often think about,
Right.
but it's essential for
Yeah.
keeping our blood sugar stable.
Exactly.
And just for our overall health.
Yeah, totally.
Think of it like this kind of
Peptides.
careful dance between what the body's keeping and what it's getting rid of.
Oh, I like that. A dance. Yeah.
Yeah, a dance.
So where does this dance take place? The main stage for all this is a tiny little tube called the proximal convoluted tubule,
Oh, wow.
the PCT,
Okay, the PCT, got it.
for those in the know.
Right, of course.
But this is where the kidneys do this really amazing thing.
Yeah.
They reabsorb pretty much all of the glucose that gets filtered out of your blood.
All of it.
Pretty much all of it.
Oh.
It's pretty impressive.
Okay, so how does it do that?
So it's a two-step process, right?
Okay.
So imagine you're a glucose molecule.
Okay.
You've just been filtered out of the blood,
Mm-hmm.
and you're trying to get back in.
Right.
Your ticket to ride is this special protein
Oh,
called SGLT.
SGLT.
Yeah, it stands for sodium-dependent glucose transporter.
Gotcha. Sodium-dependent glucose transport.
Yeah. Exactly. It's embedded in the wall of the PCT,
Okay.
and it's like a revolving door for glucose.
Okay, so it's like the gatekeeper.
It is. It's the gatekeeper,
Right.
but it doesn't work for free.
Of course not.
Right.
Now, what does it need?
It needs a sodium gradient.
A sodium gradient. Okay, so the handout mentions that.
Right.
How does that work?
This is where it gets really clever.
Okay.
The SGLT uses the energy from sodium ions
Okay.
flowing down their concentration gradient
Huh?
to power the glucose to move
That-
against its own concentration gradient.
Oh, wow.
So it's like imagine hitching a ride on a roller coaster.
Right.
The momentum of the sodium going down
Right.
pulls the glucose up.
Gotcha.
It's pretty cool.
That's a great analogy.
Yeah.
I like
Yeah.
the roller coaster.
So what keeps this roller coaster going?
Right. What's powering this whole thing?
That is another really amazing molecule.
Okay.
It's the sodium-potassium ATPase pump.
Sodium-potassium ATPase pump.
Yeah. Wow, that's a mouthful.
It is. It is.
But so what does it do?
This is like the engine room.
Okay.
It sits on the other side of the PCT cell,
Okay.
and it just pumps sodium out constantly.
So like maintaining
That gradient
it's maintaining that sodium gradient.
that the SGLT needs.
Exactly.
Wow. So it's like a
Bit of
constant.
teamwork.
Yeah, teamwork. Exactly.
Yeah.
So the glucose is inside the PCT cell now.
Right.
How does it actually get back into the bloodstream?
That part's a bit simpler.
Okay.
The glucose is at a higher concentration inside the cell.
Yeah.
So it just flows down its concentration gradient
Okay.
back into the blood
Makes sense.
through another transporter called GLUT2.
GLUT2. Okay, so it's a whole,
It's a journey
a whole journey.
with all these different players.
Yeah, very carefully orchestrated.
It is.
But, there are things that can mess this whole system up, right?
Oh, absolutely.
The handout mentioned
Fluorizin.
Ubang.
Yeah, so fluorizin is like glucose imposter.
Okay.
It binds to the SGLT,
Okay.
but it doesn't get transported.
Oh, well.
So it blocks the glucose from getting in.
So it's like jamming up
It's like jamming the revolving door.
the revolving door.
Yeah.
Wow. And what about Ubang?
Ubane is more like a saboteur.
Cut.
It targets the sodium-potassium ATPase pump.
Right, the engine room.
Exactly. It shuts down the engine room.
Oh, wow.
So without the pump to maintain that sodium gradient,
Right.
the whole system can't work.
It just stocks.
Yeah.
Wow. That's incredible.
It is. It's amazing how these tiny little molecules can have such a big impact.
Yeah, totally. So let's move on to this
Right.
tubular glucose transport curve.
Yes.
What is that all about?
So this is a way to visualize
Okay.
how our kidneys handle glucose
Yeah.
at different blood sugar levels.
Oh.
Think of it like a graph
Okay.
that shows the relationship between
Uh-huh.
the amount of glucose filtered
Right.
and the amount of glucose in your blood.
Gotcha. So like how
Yeah.
much glucose the kidneys can handle before they get overloaded.
So at low blood sugar levels,
Yeah.
all the filtered glucose gets reabsorbed.
Okay.
You won't find any glucose in your urine.
Right.
But as your blood sugar rises, you hit a point where some of those little filtering units in your kidneys, the nephrons,
Yeah.
they get saturated.
Okay.
They can't keep up.
Right.
And that's when glucose spills into your urine.
And that's called Glucosuria, right?
That's called Glucosuria.
Okay, so that basically means your kidneys are overflowing.
Exactly, like a bucket overflowing.
Right. And this threshold
Yeah.
is somewhere between 180 and 200 milligrams per deciliter.
That's right.
Okay, but what if the blood sugar keeps going up?
So if blood sugar keeps rising,
Yeah.
we hit what's called the tubular maximum of glucose.
Tubular maximum of glucose.
Of TMG.
TMG, okay.
So at this point, which is around 280 to 300 milligrams per deciliter,
Wow, okay.
all the nephrons are completely maxed out.
They just can't
They can't reabsorb anymore.
take it anymore.
Glucose reabsorption hits the ceiling,
Right.
and any extra glucose just gets peed out.
Wow, that's fascinating. So men and women actually have different values for this.
They do. The handout mentions that,
Yeah, TMG.
yeah, the TMG for men is about 375 milligrams per minute.
Okay.
While for women, it's about 300.
So men can handle a little bit
A
more.
little bit more.
Okay, so let's go back to glucosuria for a second.
Okay.
So high blood sugar can cause it,
Right.
but the handout mentions that there's another cause too.
There is.
What is that?
So glucosuria can happen
Yeah.
because of a problem with the transporter itself.
Oh, okay.
So this is called renal glucosuria.
Renal glucosuria.
Yeah, and this means that glucose is spilling into the urine
Right.
even when blood sugar levels are totally normal.
Wow.
So it just shows how important that SGLT is.
Yeah, like a faulty gatekeeper.
Exactly. A faulty gatekeeper.
Letting things through that shouldn't be going through.
Yeah.
It's amazing how all these little molecules
It is.
have such a big impact
It's really incredible.
on our health.
Yeah.
And, it's crazy to think,
We've only just scratched the surface here.
yeah, this is like the tip of the iceberg.
Exactly.
Makes you wonder, like what else is going on in there?
Could we use this knowledge
Yeah.
to develop new treatments?
Right, for things like diabetes.
For diabetes, yeah, or other metabolic disorders.
Exactly. And what about
We-
glucosuria?
Yeah.
Could that be like an early warning sign
think
for
so.
these types of conditions?
Yeah, it's really interesting to think about.
Yeah, well, that's to think about.
Lots to think about.
Okay, well, I think that's a good place
You think so?
to stop for today.
Yeah,
We've covered a lot.
we have.
But, yeah, thanks for listening.
Thanks for having me.
And we'll see you next time
See you next time.
for another Deep Dive.
All right. Bye.